Well, thank you. I'm really pleased to be here today. I always like to start usually this kind of presentation with just like a show of hand. I know usually QCon is more related to software engineering than like data science, so I would just like to know who here in like this place is like a data scientist or working with like data science. Okay. So don't worry, like I still have some slides that you will be able like to understand, like most of them usually. So let's start. So today, let's say you're like a big company like Nubank, and usually what we want to do as like working at Nubank is to be like data driven. So we collect like a lot of data, and usually we ask our customer to allow us to collect this data. And the thing is, we have a lot of personal information. As a credit card company, we have information on how do you use the app. If you are allowing like the GPS data, we know like where you are when you do like a purchase. And we have like all those information. And today, if you think about it, there is kind of like two important issues that are starting like to raise as you collect like this massive amount of data. The first one is privacy. And the second one is usually all like the company is going to use your data to make like some decision about you. So here we're not going to talk much about like the privacy, but more about like how can we, as like a company, make sure that we're not like discriminating anyone, and we're like trading fairly like all the customers that we have. So a bit of like the history is this is like a real graph in a sense that like. Those bars like represent like the real amount of paper that were published up to like 2017. I didn't like update it, but you can see that like at the beginning everyone was like, well, we don't have like that much data. Like fairness is not really like a concern for us. We might just like use like these small data sets. We have maybe like just like statistician, and then at some point you're like, okay. Like Google is like amassing like this huge amount of data. There's like a lot of value of like collecting all this data. I know there is like a lot of people thinking of, well, there is like something happening, and we need like to do a bit more research on fairness because that's something that is like impacting a lot of people. And why is it impacting like a lot of people? Today, the way we're like doing business is really like changing compared to, I don't know, like if we go back 10, 20 years ago. Like 10, 20 years ago, you might have, like just go to like some like merchant to be able like to get the lending, or even like in hiring. It's like you're just like talking to people, like the person in front of you doesn't really know you. The only thing he knows is maybe like your resume. And today, what you have is you are asking like again like this customer to give you like a lot of information. So for hiring, there is like some, I don't know, let's say like companies that are going like to go on Facebook and start like to look at what kind of picture do you have there, and then you are going to say, well, I don't really want to like this company to know that like last Saturday I went drinking, and I don't know, it has like nothing to do with the fact that I can be like a good customer or not. And here, what we have is we have like a lot of different area like mortgage lending, even like prison sentencing. You might have heard like more and more today, in a sense that it's kind of, if you've seen like Minority Report on like trying to predict in advance what like people are going to do, and to be able like to stop a crime before even it happened. But the thing is, in those examples, and especially like if we take like the prison sentencing, you're like putting the life of people on the line. It's like you're going to say if this person is going to spend 2 years, 5 years, 10 years in prison, and he has like a really big impact on the life of someone. And at like another level, here, like in the case of Nubank, our issues usually are more related to like, should we approve the customers? Should we increase like the credit line of someone? And this is also like at like another level, also impacting like the life of someone, because as Nubank, what we really want is we really want like to improve the life of our customer by giving them like the best credit line, so they can have like access to like credit, and they can be able like to, I don't know, like pay their bills. They're able like to, I don't know, do like stuff that they couldn't do like before. So don't worry, you don't really need like to read everything, but there's like this interesting paper that kind of like compiled all those kind of like different definition of fairness. So you will see like in this presentation a lot of kind of like different metric, different way you can compute that. But this is kind of, like I don't know, like a good representation, good summary of everything that you can see. Here there's like 20. Usually there is also like, I don't know, around 20, 21 definition of fairness. And something that is interesting is it's impossible to satisfy all those definitions. So in some sense, even if you want like to be like the good guy and you want to make sure that you're not like biasing like your customer, in some way you will always like bias some part of your population. So it's going to be like really hard, and what I want to, I don't know, kind of like pass as a message is this fact that we can try. It's going to be hard. We're not maybe going to succeed for like all the customer, but the thing is like if you don't try, it means that you're not going like to do a good job. And as data scientists, you have like this responsibility to make sure that you're like being fair with the customer that you have. So again, if you look at like the second point, you can see that like the research is very active. So we have like all conferences that are like being created just on fairness, on ethics, on transparency, for example. And today there is no like clear like metric that we can say this is like the metric that everyone should use, because depending of who you are and what you're doing is going to be like really different. And same thing is going to again like depend of like what you're going to do. So let's take like this example of present sentencing. So for those who doesn't know like what is this kind of like square, is in machine learning what we call like a confusion matrix. So if you look at if you look here on this line, what you will have is usually people that you're like labeling. So you're predicting that those people are going to be like kind of like low risk. So I don't know, you did something and you're going like to get like all this data about who is this person, maybe like this gender, where it's coming from, what was like the crime he did, if he did like some other crime before or not. And then you're going to label this person as either like low risk or high risk. And then what is going to happen is you're going to take like the decision of, am I going to send him to prison? Am I going to keep him, like inside society? And then usually what you will have is you will have after like some point, maybe, you're saying, okay, well, I'm going like to look at this person back after 1 year. And after 1 year, you're going to see, did this person like, I don't know, maybe like did a crime again, like he recidivates, or maybe he didn't do anything. And then depending on what happened, so if he was like labeled high risk and he recidivates, then you were right, so it's like a true positive. If he was labeled like high risk and he didn't recidivate, it was like a false positive. So you made the action, but in fact, the guy didn't do anything. So we're going to take that, and we're going to see that depending on who you are, the definition of fairness is going to be like really different. So let's say you are a decision maker, and what you really care is you just want to put like the people, like the high-risk people, so that's like the only person that you care. You want to put them into prison because that's like the most dangerous people, and that's like the only thing you want. So what you will care is only like kind of like this column of like high-risk people. Then, if you're like a defendant, what you care is, well, you don't want to put like an innocent person in jail. So we are going to care is like all those people that did not recidivate, either if you like your model label them as low risk or high risk. So that's going like what you care about. And then you have society. And society, well, what we really want is like we want to be fair with everyone. We don't want to put bad people in jail, but we also don't want to, we want to make sure that like all the really bad people are going to jail. So it's going to be like hard to just like kind of like satisfy everyone. And here again, you don't have like to read everything. This is like taken from Wikipedia. Here, this small square that you see here is like the confusion matrix. And as you can see, from this confusion matrix, you can create 18 scores. So you can just like look at true positive value, you can look at true negative, and then there is, like everything derived from that. You can look at false positive rate, specificity, prevalence, accuracy, and each of those scores is kind of like something that you care about, and that can be like useful for maybe like the decision you're taking. So just before we continue, usually in this field of like fairness, there is this like terminology that you need like to understand a bit to be able like to like read all those papers. And the first one is what we call like a favorable label, and usually is like a label or a target in a sense of like if you're doing like modeling, that is like providing like the advantage to someone. So in some sense, like here, what we are trying to do is maybe like being hired or not being arrested or even like receiving a loan or being accepted at new bank. Then you have like a protected attribute. And usually this attribute is the thing that you want to make sure you're not like discriminating people on. And here we might like talk about race, we might talk about gender, religion. I know there is like a lot of like different way. And what's interesting is usually depending of again what you're working on, some of them might not even be like discriminatory because you really want like to make sure that I don't know like for maybe like some specific position. I cannot like think of one right now, but like you only want male, for example, or like female, for example. So in some sense, like predicted attributes are not like universal, and it's going to be like really specific to like the application that you're going to use. Then you have like the privilege value, which when you look at like the protected attribute, is usually if you look at race, gender, and religion, is going to be which of like if you look like a bit deeper, is going to be like if we look at race, it can be like the privilege value is going to be maybe if you're like white, and then like the unprivileged is going to be more of if you are black, and it's going to be like the difference. Or for gender, if you're like a male or if you're like female. Then you have like group fairness, and here usually like the goal is just to make sure that like each of like the group that you have in those like protected attributes are treated in the same way. So you don't like giving an advantage to one group compared like to the others. And then you have like individual fairness, and here is usually like to make sure that like similar individual are going to get like the same kind of like output treatment from like the like model, for example, that you just built. And then we have like bias, so it's a bit of like what we are like going to talk today on kind of like the systematic error. Is usually like the bias is we get data, but usually this data was generated by like human from before. And usually what's happening is humans are usually like fallible, so we can like make bad decision or just like decision based on like this morning I woke up and I felt that it wasn't a good day. So I'm going like to talk to all those people that I'm going to like hire, and maybe like the whole day I'm going to just say like I really hate everyone, and even if the guy is good, I'm just going to say you're going to be like disqualified, you're going to be disqualified, you're going to be disqualified, and then at the end like it wasn't based on anything from data but just from like your feeling. So that's like kind of like what we want to remove from like the system. And then you have here the way we're going to look at if we're doing a good job or not on removing this bias is by looking at like some metric. So we're going to talk about like fairness metric, and usually just going to be like again like some metric that are going like to quantify how much we are being like biased or we're being like unfair to like some specific group of people. And then like some of the solution we're going to talk about is what we call like bias mitigation algorithm. So the goal is at some point you can like leave this room and just think, okay, well, like there is still hope, and all the data that I have, maybe I can do something about it. So by the end of like this whole process of like my prediction is going to be fair with a bunch of people. But wait, there is like this issue. It's like you're telling yourself, I've been here before, and I know that it's not good like to discriminate between gender, race, or even like religion. And how I can do that is really easy. I'm just removing like every feature like race and gender. So I'm being fair. Like the feature is not here. You cannot tell me I'm like being unfair because I'm not even using it. And usually that's not really like a good argument. And you can see it here. If you don't know it, it's a map of the Chicago area. So here in the middle, if you see the pointer, is going to be like the center of Chicago. So it's usually like the financial district, so you don't have like much people living here. And then you see like all around is the different like neighborhoods, and every point that you see is going to be like a person. And here you can see that most of like those neighborhoods are already like discriminatory against people. Here you can see that usually in the north of Chicago is like well known that it's mostly like white population living there. In the south of Chicago, it's usually like the black population. In the west, it's usually like the Hispanic and black population also. So in some sense, let's say you're doing like some analysis and you're saying, okay, I'm removing the race of someone, but like I'm a credit card company. At some point, I need like to send the credit card to someone, so I have like to get the address of this person. And then like maybe like another data scientist is thinking, it's been a while that my model is stuck in like this prediction and is not doing that good. And maybe what I can do is have like all those like geolocation data about people. Maybe I can use it, and I'm pretty sure I'm going to get like some pretty good bump in my model. But the thing is, what you can see here is you're not using gender, that's right. But there is like this huge like segregation that you can see. So in some sense, I don't know, like use, let's say like a random forest. This random forest is going to be like really good to just like separate here and saying, okay, well, all those people south of here are going to be, you know, like some population. And some people between here and here are going to be like another population. And in fact, what your model is going to learn is just going to learn where people are living. And at the end of the day, you're just going to learn what was the race of the people living in this neighborhood, which is like pretty bad. So if we go back to, you know, like some of those like fairness metric, what we have is, again, you know, like this confusion matrix. Usually it's kind of the easiest way to do stuff when you're doing some analysis. And again, you know, you might have like all those different metrics. Like I'm not going to explain to you everything, but again, you're like true positive, false positive, true negative, false negative, and you have all of that. But then you can have like a bit more fancy metric. So there is some that we call like difference of mean, disparate impact, statistical parity, odd ratio, consistency, generalized entropy index, and let's take some of them. So if we talk about like statistical parity difference, and usually you can find like in the literature some of those names, so group fairness, equal acceptance rates, or even like benchmarking. What you want to do here is you want to look at the prediction that you have at the end, and for everyone, let's say, I don't know, like let's say that you are hiring, you're just going to, you know, kind of like filter everything that every people that you hired, and you're going to look at like the probability of the people that you hired and is from like the group that you want to control. So let's say here's like the gender. Those probability are going to be the same, or at least like pretty close to each other. Because if you have a huge difference, it means that there is like something wrong that you're doing, and then you need like to kind of like unbias this data. So at the end of the day, your model that you're training is going to be unbiased, and you're going to make better decision for those group of people. And yeah. The other one is what we call like disparate impact. So again, like a lot of them are just, you know, like byproduct of this confusion matrix. So let's say you have, you know, like your predicted values, and let's say here is going to be like your true group. So it can be, you know, like either you're like male or female, and you're going to see what is like the difference between like those different ratios. And usually there is this really funny 80% rule, where if you're doing like the ratio between one of the group between like the other group, what you want to do in some sense is you want to have like this 80% rule where the difference between those two groups in some ratio should be like always above or equal to 80%. And we have that because it's kind of like a rule that happened in the 1970 in the US, where for at some point when people were used to hire in like some company, to make sure that you weren't discriminating against maybe like gender or maybe against like some race, you had to make sure that like if you computed this ratio on like the group that you were hiring, this ratio should always be like above 80%. So there is usually, you know, like some library, and I'm going to talk about them just like a bit later. Aikitas is one of them. And usually they have like this approach where they just like give you kind of like this tree of, okay, well, you want to make a decision, let's go, you know, like through like this tree where like the first node is, do you want to be fair based on disparate representation or based on disparate error of use on your system? And then you choose like, oh, okay, I'm caring more about like representation or error. And then let's say I'm caring more about like representation. And then you have like this other question on, do you need to select equal number of people from each group or proportional to their percentage in the overall population? And then let's say here, what we care about is maybe like the proportional, because in some sense, let's say we have like maybe, you know, like this problem in data science where, let's say I'm doing hiring, and in hiring usually the number of resume I get from female candidate is going to be like way lower than like male candidate, and usually it's just because in like the population of people doing, you know, like study in the area of like data science, machine learning, usually you have, you know, like this really imbalance where you have more men than women. And maybe here what I want is, okay, well, this is like the number of resume I have, and usually I have only like 50% of those resume that are from female member. And what I want to do is, well, I would like to be like really fair and have like 50-50, but it's going to be like really hard for me because in some sense like my proportion inside the population is only like 50%. So maybe like what I will want to do is I want to care about like the proportion only and not like have an equal number. And here at the end of the day, what I will do is, okay, what I want is kind of like look at this metric which is like proportional parity, and what we called just before is like the disparate impact. So if I look at like the ratio, I should have like this ratio of like 80%. It's not working well. So how about like some solution? So far I talked about like the metric. I talked about how you can know if your data set is biased, but what you care about is, well, if I know it, like, how can I do, like, what can I do, like, to change it and to be able, like, to be a bit more fair with people. So, you can use like some disparate impact remover, do some relabeling, learning fair representation, or maybe you can do like reject optional classification or adversarial debiasing, or maybe you can do rating or additive counterfactual fair estimator. So you have like a lot of them, and usually at the end of the day, well, I advise you like to not just re-implement everything because it's going to be like really long, hard, and today, like in data science, you have like all those really good library, and this is like a list of library that are like available. I think it's like pretty extensive. Usually it's like the main one that are like a bit more like popular. And here, the one I put in red, I don't know, like the one I tasted, and I feel that they are like kind of like pretty good in what they're doing. And most of them are like in Python. So if you're using like tool like scikit-learn, there is some kind of like compatibility where here that's going to be like one of the tools I'm going to talk about, which is AIF 360, which is a tool from IBM. And what's interesting with this tool is it's compatible with scikit-learn. So it's based on like the paradigm of transform, fit, and predict. So it's really easy like to just like incorporate inside, I don't know, let's say like a pipeline that you might have, and to just have this whole pipeline running and to be able at the end of your prediction to be to have some fair prediction. It's not working. So let's go back to like some solution. So how can we fix like those prediction? And something that is really interesting in how we can do that is there is like 3 ways to do it. As you can know, like usually when you're like building models, there is like 3 steps that you might have. The first step is you have like to build your data set. And when you're building your data sets, what you can do is you can already like have a step where on this data set, before even you like train a model, you're going to do like some changes that are going to make this data set like a bit better when you will like feed it to your algorithm, so it's going to be like a bit more fair. And then you have in-processing. So in-processing is you're going to look at directly at the model you're going to choose, and this model you're going to make like some transformation. So the way it learns on your data is going to be, again, more fair than if you didn't do anything here. And then after you train your model, you have your prediction. And here is again like one more time where you have like the possibility to look at those prediction and to be able like to do some transformation on those prediction to be more fair on people. So there is like this diagram that is like pretty cool, taken also like from the AIF 360 paper. So like everything, you start from like raw data, and then from this raw data, usually you have like your original data set. So if you know like the good practices in building model, usually you have to like get a training set, a validation set, and testing set. And then from here, you have like 3 different paths that we talked about before. So one can be like the pre-processing, and the pre-processing here, what you're going to do is you're going to take like this original data set, you're going like to pass it through like this function method that you have, and then you will have like this transform data set that is usually a bit better to feed like inside your classifier. And then at the end, what you will end up is you will end up with like fair predicted, like a fair predicted data set. Or otherwise, we go back, you have the raw data, You do your different splits, and what you can do is you can just like put it inside a fair classifier. And this fair classifier is going to do like the work, and I'm going to explain like a bit of each of those like after that. And same thing, you do like the fair in processing, and then you will end up with like a fair predicted data set. Or last point, again, you go back to original data set, do the split, you go there and you put it inside like the classifier, you have your predicted data sets, you do some post-processing, and then at the end you end up again with a fair predicted data set. So what are those like different methods we can use to do that? So in preprocessing, kind of like the most well-known in the field is usually like just rating. So usually you have your training set, and the only thing you do is you're saying that like each of the sample that you have in this training set is going to have different weight, and usually those weights are going to be chosen relative to like what you usually care. So let's say you have like underrepresentation of, let's say, like women in some data sets. You're going to just like put this weight higher than usual, and you're just going to reduce maybe like the weight for all the male in the same way. And then you have optimized preprocessing. Here, what you're going to do is you're going to learn probabilistic transformation. They're just going to change like the feature that you have inside your data sets. Then here you might have something else that we call like learning fair representation. So here, something related a bit is, for example, if you're doing embeddings. So you might say that, okay, well, I don't want to like, be able like, to look at my data. I'm just going to feed this data inside like some embedding, and the embedding I'm going to create are going to be just like numbers that are going to represent still like my data, so I can still like learn some stuff on top of that. But the way I'm constructing this embedding is going to make sure that I cannot like recover the productive value that I had before, which again can be gender, religion, race. And then the last one is what we call like a disparate impact remover. And here, something that like the second one here, what we want to do is we want to edit like the features just to make sure that we increase like the group fairness and preserve some rank ordering that we might have in some of the group that we have. The second one is in processing. So in processing here, you are like to touch the model, and here kind of like the two main way you can do that is usually in adversarial method. So if you know about GAN, which is like generative adversarial network, what you're going to do is you're going to have kind of like two models. The first one is just going to learn your data, and the second one is going to learn if on the prediction of your first model, you can also learn the prediction of like the predicted value that you had before. And what you want to do is you want to make sure that at some point, the second model is not able like to differentiate anymore on like the predicted value that you had before. Then you have here a prejudice remover. And here, what's interesting is you just take kind of like the model that you have, and as regularization that you might have when you have, let's say, overfitting and you want to do like some regularization, you can add like a term at the end of like the formula that you want like to optimize, and this term is just going to be like a term that is making sure that you're not going like to discriminate again against like the predicted value that you had before. Then you have the post-processing. So here the post-processing is you went all the way through, you have your prediction again, and there is like those three methods usually that you have, which is equalize post-processing. And here you want to solve a linear program to find some probability. So if you change like the outputs, you're like optimizing some, like here the metric that is equalize odds. And then you have calibrated equalize plus odds post-processing. Again, you want to just like calibrate like the score that you have at the end, just to make sure that this metric is optimized. And the last one is reject option classification. And here, what you want to do is you just want to make sure that like the outcome that you get. Let me see. This one I don't know much. The favorable outcome to like the unprivileged group and unfavorable outcome of the privileged group are like in some confidence band that usually you have. So just want to make sure that you're getting like the data inside some confidence interval that for you is like good enough for what you're doing. So let's take a look now in some experiments. Those one are also like taken from the AIF 360 paper. And usually in this field of like fairness and bias, there is like three main data sets that people are using a lot. It's usually like pretty small data sets. And the first one is like some adult census income. So it's just like a data set where you have some information like the gender of someone, if the person is married, divorced, I think maybe like where the person is living. And then at the end, usually what we ask those people is how much they're making. And usually it's going to be like a range. For example, people are making like less than $50,000 a year, or more than 50,000, or more than 100,000. The second one here, German credits, is a data set where same thing, you have like some customer that has for some credits. And what we get at the end is mostly like, did this person like receive the credit? And I think, I don't like if he received the credit or if he managed like to pay back this credit. And then Compass, the last one, is the data set related to like sentencing. So a bit of like the example I showed you before. And then what we're going like to look at as though like, are those 4 different metrics. So disparate impacts, SPD, average out difference, and equal opportunity. And then we're going to train those 3 different classifiers. So logistic regression, random forest classifier, and some neural nets. And what's interesting with like the take of like taking that, usually like a logistic regression is kind of like a baseline that people will usually like choose when they want to train a model and kind of have a benchmark. Random forest is a bit more like, I'll say, well, not complicated, but usually performing always like a bit better than the logistic regression. And then neural nets, I don't know, maybe it's like the hype. And then we have like those different processing steps that we talked just before. And now let's look at the results. So here what you want to see is here there is like the 3 data sets. So you have like Compass, the credit one, and the census. And here for each of those you can see that there is like 2 predicted values that we'll like look at. So for Compass it's going to be like sex and race, sex and age, and sex and race again. And here is going to be like the metric. So in blue is if we look at like the data sets before we do like this pre-processing and we just look at this data set and compute this metric, what you will see is we'll get like this like score if we look at like all those like predicted values. And what we really want for SPD is to have like to make sure that we have like a fair value. Usually what we want is we want this metric to be like really close to 0. And sorry. And as you can see, before the pre-processing, we're like kind of like far from it, and after the pre-processing, we're like closer from it. So we have that here for this technique, which is like reweighting. And if we use like optimized pre-processing, we have like the same impact, although like a bit like bigger than what we will have if we just do like the weighting. Then we can do the same if we use, let's say, like the metric, which is like disparate impacts. And here, what we want to do is for disparate impacts, having a fair value means that your value should be like pretty close to 1. And here, same thing, we use like those 2 different pre-processing techniques. And you end up with like if you start with like the blue to the orange, and you see that we're like closer to 1, so it means that your data set was changed like in a better way, and it's going to be like fair, more fair for people. And then we can look at like the results. So here those results are taken only from the census, and what we try like to control, so like the predictive value that we had was, if I remember, I think it was race. So let's just look at maybe like the best model here. So above here, this line is before like the pre-processing. So if we look at like statistical parity, you might see that it's not like close to 0. And you can see that like the accuracy of this model here is pretty close to, let's say, 70, I don't know, like 77, 76 accuracy. So we have that for this model. So same thing for disparate impact. It should be like closer to 1 to be fair. So it's like a bit like below. And then we apply like this transformation. And what you can see is usually, so here like for those two methods, you have like logistic regression and random forest. Here you can find them again, logistic regression. So you have like a bit of loss of accuracy. So you went from like 77 to maybe like 75, 76. But you got closer to like the 0 here that we care about. And let's say if you took like the logistic regression, then here for the logistic regression, you managed like to arrive to a really fair model. But maybe you lost like a bit more from maybe 74 to let's say like 73. But like the takeaway from here is at the end, you can see that you're not losing that much by being like more fair to people. Your accuracy is not like dropping by much, but as you can see, is usually you can get like way more fair model related to like those metrics that we are seeing. So in some sense, if we look at let's say other results again, here we're choosing like other metrics. So here we're choosing like average odds difference and equal opportunity difference, and here we're seeing like the same kind of like conclusion. We went from having like the model that is again like pretty close to 76 to having again like another model pretty close to 75, 76. So not losing much accuracy, but being like more fair overall. So that's all. I'm not sure if you have maybe any question.
Oh, thank you very much. We have time for questions. Anyone? Okay, well, I have a question to begin with. You said you show here that you have this small trade-off in accuracy when you apply some of these methods, and have you encountered a situation where this trade-off in accuracy is actually quite significant? And how do you think you usually should deal with that? Because if the trade-off in accuracy is quite significant, I believe we may find some pressure to not apply some of these methods.
So there is sometimes like a really huge decrease in accuracy, but it comes usually like, let's say, if you're trying like something that you shouldn't try. Let's say like one day you really want to know, okay, well, what if I'm putting gender? Like, what is going to happen? And like at Nubank, usually we try to like avoid that from the start. We know like the different feature that we might use or not, and depending of like those feature, we're going like to take a look. And maybe one day you want to say, okay, well, I really want to see like the real impact of using this feature, and you go and you see like this impact. But the issue is today we don't really have it. But if you think of Europe, and it's going to come like next year in Brazil, you have like law like GDPR, so like the data protection law, that is going like to like force companies to reveal if like the prediction you're taking from like which feature are they coming from, So if at some point you're like saying, okay, well, my feature are coming like from gender, then you're going to be like in some trouble because, in our case, for example, like the central bank can come and say, okay, well, what you did is like really bad and you need to remove it and maybe, get like some penalty or even like remove some license if we do like something really stupid. So we want to be like really careful on that. And here what we want to do, like when we do like all those research is we want to go like let's say like the last mile of making sure that even if you remove those features, and that's what we saw before, is like just removing gender doesn't mean that your model is not able like to find gender again, like in the other feature that you have. So usually what we want is we want to make sure that those features are not present like somewhere else. And in my experience, usually because you don't use like the real one from the start, the decrease in feature is like not that much. And it doesn't have like that big of an impact. And again, like at the end of the day, well, you can be like better and have like a better accuracy, but you still want to keep your license. You still want to be, like, in the case of Nubank, I don't know, like people really love us in some type of like public relation, and we don't want to like break this relationship with our customer, and that's why we want to make sure that we're like fair with them.
Okay, that's a good point. So if you start by not having this data in your data set in the first place, I think you're not so tempted to to start using it. Okay. Questions?
Well, the example that you showed us is an example based on structured data. And do you have any experience or know of any work under unstructured data like image or videos that especially for face recognition and stuff like that?
So there has been like a lot of study on that, because not so long ago, I think someone did like a study on, let's say, like every like face recognition algorithm from like Amazon, Google. I'm not sure Google is doing it, like Amazon, IBM, Microsoft. And what they saw was this model was doing pretty good for, let's say, male people, either they are like black or white, or even like female people that are white, but really bad for female people that are black. So usually like the way you're going to do that is you have to like create a data set that is kind of like balanced, because usually like from the start, some of the like few data set that we had at the beginning to train like face recognition, it was mostly like extracted from maybe Google, and it was maybe like just like stars, movie star that you had, and because it was really easy like to get the data. But the thing is like usually like movie star, like if you think about it, you might have like a like more representation from maybe like male, maybe like white male, or even like white woman than like black woman, for example. So they find that. And at the end, it was like really easy like to fix that, because the only thing they had to do was, okay, well, we just need like more data from like this underrepresented group. And then, like they did that, they retrained, they look at the data again, and then, like everything was back to like normal, and they were able like to classify everything.
More questions?
Hi.
Hi.
In your talk, we saw lots of things related to the code and the process and the data treatment in order to lessen the problem regarding sexism, racism. Do you think there are other areas that we could improve in order to lessen the problem?
That's interesting. I think where it's usually like complicated is like all those like solution that I showed you so far. It's kind of going on the fact that you have like those predicted value. So in some sense you have this information of, let's say, the race of someone, or the gender of someone, or maybe like the location of someone. But let's say you don't have this information, and let's say, how can you say that you're like discriminating against this population if you cannot even compare that like this population is like discriminated? So that's where there is like this research of, let's say, I don't have like geolocalization of like people, but in my data, because of like some issue, like one feature is in fact like a proxy for like this information, but I don't know it. And the thing is, like my model, I'm training it, I'm saying, oh, like this like feature is like really good, and I'm really happy because like my model is really good because of that. And you put it into production, but in some way, maybe you're like discriminating against like someone, but you don't even know it because you have like nothing to compare. And that's where it's like really hard, and that's where I don't know. That's kind of like the interesting part of how can we remove like this bias that we don't even know, Like how can we find it? And usually you find it because, again, like when you're like a data scientist, you might like just look at the data, and we've been like in a lot of cases where you start like to see, like a feature like really good, and you're just wondering, why is this feature really good? It doesn't make any sense, like you just like put it every feature that you have, and I don't know, let's say something that is not related. There was something about if people were going to, I think, like pay back some money, let's say something like this. And we saw that like the number of email we were like exchanging with people was like really important. And you're like, oh, that's like pretty good. I would just like put email as a feature. But in fact, what we saw is, email is like an important feature, because even before you classify this person as, someone that you need like to contact, maybe even before, like some people were like thinking, okay, I need like to contact this person in advance because I want to make sure that like everything is all right. If maybe I can help him in, like before, And then you arrive like to the situation where your model is just like looking, okay, well, you already started like to contact this person, but in fact you contacted him because you already know that this person was like in difficulty. So it's kind of like a feedback loop that you want to avoid, and it's like pretty hard like to understand, except if you really like go deep inside the data and you understand like the whole situation, and you don't just stop at, oh, like this feature is good, my job is done, I'm going home, I'm happy, you know.
All right, that's a fascinating subject. Thank you very much.
Thanks.